Okay, Bismillahirrahmanirrahim. Let me show you another software which is very useful for solving linear programming, QM for Windows. Just open this. And you can see that there are so many modules there. Let's close this up, and we have if you go, we can see the linear programming here, and just click on this one. And when we click on this one, we get a new window here, and it's very easy. How many number of constraints? We can just increase this number of constraints. We can number of variables, we can increase them, decrease them. We can give a title if you like, maximize, minimize, and so on. So we will solve the same problem as Bowles and Marx. I will show you the same problem and try to solve this. So we just say there are two constraints are there, two variables are there, and it's a maximization problem. We say okay, and we say okay. We get the a nice table here, and that's very easy. Just fill this up. We have $40 for X1 and $50 for X2. So you can see on the side the equation is also coming, and then here the constraint one is 1x1 plus 2x2 is less or equal to 40, and the second constraint is 4x1 plus 3x2. And again here we can by clicking on this one, we can change to equality or greater or equal to, so it is less or equal to, and no problem here, 120, and this is done. So now what we do is just go to solve here, and when I click on solve, we will get the answer here. And this is interesting that we have a solution where x1 is equal to 24, x2 is equal to 8, and z is equal to 1360. You can see also dual here, 16 and 6. Dual is basically the shadow price. It is also called dual price, dual value, shadow price, different names, same thing. It is the worth of 1 unit of that resource. We interestingly also we get a lot of windows. We can get the ranging, we can get the solution list. Ranging is the same as sensitivity analysis here, and solution list iterations. This is the iterations of simplex method. It can show that the dual values and the graph. And the graph, for two decision variables, we also get graph. So graph is important here. Let's look at that graph. And we can see that the graph is here. We have x1 and x2, and we can see this is the feasible region given in what we call it, aqua color or something like that. It's given in that, and we can see there are 4 corner points, 0 0, the z is 0 0 20. We have 1000, z and 30 0 is 1200, this corner point, and finally the 24 and 8 corner point we have 1360. It is also showing the ISO profit line, which is passing through this corner point. So very interesting. It's very easy to use. I recommend that you download this QM for Windows from the book and use it. You can test your ideas. You can see how it varies. Also, in the solution list, we can get the ranging. The ranging is the same as the sensitivity analysis. We have x1. X2 original value is the value of x1 and x2 is 24 and 8. Their coefficient values are 40 and 50. The lower bound and upper bounds are there, which was C1 25 minimum and maximum 66.67, and C2 is 30 and 80. In Excel we get allowable increase and allowable decrease. Here we are getting lower bounds and upper bounds the same way we used to write it, like C1 upper value and lower value, like here. Okay, it doesn't work here, no problem. We don't want we can get in. Okay, and the constraints also, we can get the dual values. We have dual values. These are the shadow prices, 16 and 6. Slack and surplus, it's showing any slacks. Since we have dual values which are positive, then slacks will be 0. And the original values are 40 and 120. And the lower bound and upper bound of these resources. So this is interesting. It also shows the iteration in simplex method, since we have not done the simplex method, but it shows as well the ranges, the iterations as well. All right, now what we do is we go to our presentation, and there are small things left. One is about the other forms of sensitivity analysis. We are changing in individual constraint parameters, which are called technological coefficients, adding new constraints, adding new variables. Now for this kind of sensitivities, to testing that, we have to actually repeat the analysis, resolve the problem. So changing individual constraint parameters, we have over here the coefficient, technological coefficients are changed from x1 plus 2x2 less or equal to 40, we have changed to 1.33 x1, and we can see that the corner point is now changed. So we have to actually repeat this. It's just showing that we can do also changes in technological parameters to see the effect. Here we have added one more constraint. Packaging constraint has been added, and again we can solve it, resolve it, and see the sensitivity. Other form of sensitivity analysis is adding a new variable. If we add a new variable, let's say instead of just making bowls and mugs, we are also making cups as well, and we have the two constraints again, the labor constraints and the clay constraints, and then we can solve it again. And remember that when we have more than two decision variables, we cannot plot them. Okay, the marginal value and sensitivity, shadow price, we have already discussed that. I will just skip that part. And then just an example problem here for us to do some tutorial. Okay, let's see one example problem just to have our concepts embedded in our minds firmly. So we have these two airplane parts, number 1 and number 2. They are making two parts, some company, and there are 3 manufacturing stages are there: stamping, drilling, and finishing. 3 manufacturing stages are there. And the decision variables are x1 is number of parts of number 1 to produce, and x2 number of part number 2 to produce. Model is maximize z is equal to 650 x1 plus 910 x2. This is the profits for each part, and then subject to 3 constraints are there: stamping hours, drilling hours, and finishing hours. And these constraints are given, and of course non-negativity constraint is there. So what we do is we will just look at the solution, and this is our solution here. The optimal point is at point B. the corner point B is there, and its coordinates are x1 is equal to 5.97, x2 is equal to 10.82, and z is equal to 13,722.49. This is the formulation again. Now let's see, we want to find out the range of C1, the coefficient of the first decision variable, the profit, how much it can vary without changing the optimal point, and that optimal point is point B. So to solve this, what we do is we make it z is equal to C1 x1 plus 910 x2, and from here we can get x1 is equal to z over C1 minus 910 x2 over C1. Okay, and we do the same for three constraints. We have three constraints, so we find out the slopes for the three constraints here. x1 is equal to 105 over 4 minus 7.5 x2 over 4. Then we have second constraint, x2 is equal to 90 over 6.2. Okay, then minus, what happened, 9 minus 4.9 over 6.2 x2, and sorry, x1 should be x1 here, right? And then we have the third constraint, get the slope of that one. The third constraint is x1 is equal to 110 over 9.1 minus 4.1 x2 over 9.1. Okay, now we equate this constraint with the objective function slopes. The objective function slopes is equated with the slopes of these three constraints to find out the range. How much the objective function coefficient changes such that the optimal point remains optimal. So we have here 910 over C1 minus equal to minus 7.5 over 4. So what we get is C1 is equal to, and I will use my calculator, then similarly minus 910 over C1 and equal to minus 4.9 over 6.2, and C1 is equal to, and the third one is minus again 910 C1 equals to the third constraint slope minus 4.1 over 9.1, and C1 is equal to. All right, let's use the calculator to find out. So we have 7.910 multiplied by 4 divided by 7.5. We get 485.3. 485.3. The second one we get is 910 multiplied by 6.2 divided by 4.9, 1151.4 Okay, we don't go to the second decimal. And then the third one is 910 multiplied by 9.1 divides by 4.1. What we get is 2019.8. 2019.8. Now we see that the original value is 650, right? And we have two values coming downward and one upward. One downward, which is 485.3, and two upward. All right. So we can write down that C1. Okay. Lower is easy. We just say 485.3, right? And the upper is, there are two values. One is 1151.4 and another is 2019.8. You can see which one is more sensitive, which one is more closer to 650. And the more closer is towards 650 is 1151. This is more sensitive, so 1151.4. This is the range over which the corner point is not gonna change. Okay, so if I may show you the result, and the result is the same. We have, if I remove this one, okay, C1 is 485.3 and 1151.43. This is our answer. I remove now everything here and try to find out the, let me remove it, all this, and we will now see the right hand side also. And then I leave it to you for finding out the other coefficient. So I suggest that you work out C2. I will now work out for the right hand side value of stamping. Now stamping constraint is this one. This is stamping constraint, right? This is stamping. And we would like to see how much the quantity value changes such that the mix in which x1 and x2 both are there, and the s1 and s2 are both s1, s2 and s3, some has whatever the value they have. If any of them has zero value, then it will stay the same. The other two variables have some positive value. At the moment I really don't recall, but S1, S2 and S3, whatever the values are, they are here. Okay, S1 is equal to 0, S2 is equal to 0, and S3 is equal to 11.35 hour, which means that the finishing constraint has slack hours, which can easily be seen from here also, because as you can see that it is not touching the optimal point finishing constraint, and we have to increase it to get it in the optimal mix. It is not there at the moment. So what I would like to see is this, that how much this stamping right hand side, which is at the moment 105, changes such that the solution variable mix, which means that x1 and x2 have some positive value, s1 and s2 are 0, and s3 has some positive value, remain same, or the shadow prices of these constraints stays same. We would like to see that range. Now, how do we do that? We stamping constraint, you see over here, it is at point B. If we increase this stamping right hand side, the constraint will start moving away from the origin. It will go to this side, right? And the point B will start moving until it will go to this point. Now what is this point? This one is x1 is equal to 0. x2 we can work out. How can we work out? We can see that this constraint is drilling constraint. Okay, so for drilling constraint, if we put x1 equal to 0, we can find out x2. So in the drilling constraint, x2 is equal to 90 over 4.9 will give us the point here. 90 divided by 4.9, 18.37, let's say 18.37 roughly speaking. All right, and this point now we just plug in this value in the first constraint, stamping constraint. So we have 4 into 0, x1 is equal to 0, plus 7.5 into x2, which is 18.37, and this will give us Q1 maximum. Okay, so Q1 maximum is multiplied by 7.5. What we get is 137.755. Roughly speaking, 137.8. Let's say Q1 maximum is equal to Q1 we are looking for this range. Sorry, the maximum is 137.8. And let's look at the lower side. Now for the lower side, we will be moving stamping constraint towards the origin, to this side. When this side we are moving, this point start moving downward, and it will have a corner point. Okay, my battery is running low. Let me fix it. Okay. All right. Now this is moving, point B is moving towards the origin, and it will be, the new point will be at point C. Corner point will be shifted. This corner point, when it is shifted, we will have a new variable mix, and we will have also S1 and S2 and S3 will have if any of these change will be there, some changes will be there, right? I don't know, we have to check by running the software, but what I can say is this, that the variable mix is gonna change from point B to when we shift it to when we move the constraint, stamping constraint towards the origin, and it will have a new point which is point C. Also the what we call these shadow prices will be changing as well. All right, then this point C, we already know the x1s and x2s are there. Okay, so just plug this x1 and x2 in the stamping constraint, and we will get the value. So we have 4 into x1 is now 8.87 plus 7.5, x2 value is 7.15, and this will give us Q1 minimum. Okay, so which is let me make calculator. 4 multiplied by 8.87 plus 7.5 multiplied by 7.15, and what we get is 89.105. So we will have 89.1. This is the range over which the shadow prices of constraint 1 is valid, and the shadow prices are valid, and if the right hand side varies between these two extremes. All right, and as a homework, I would say that you find out the C2. You find out C2, upper and lower limit. Find out Q2, upper and lower limit as a homework, and find out Q3, upper and lower limit. This is your homework. Just to tell you that if we have to work out for drilling constraint, we have Q2 here, and look at the drilling constraint, and in the drilling constraint, if we move the drilling constraint outward, the new corner point, if we move outward, is this one. Okay, so you have to work out the intersection between finishing constraint and this constraint is finishing and stamping constraint. So this point you have to work out, solve it, and you will have for the Q2 maximum, and for Q2 minimum you have to move this towards the origin drilling constraint, and it will be point A there. Okay, so you will work out for Q2, and similarly you can work out for Q3, etc. I suppose okay, this is the Q1. We have done it correctly. Now we have the, okay, we can do it, solve it by Excel. We just model it and solve it. I can show you in the Excel as well. We have done it. This is the formulation here, and the sensitivity report is there. So here we can see that the shadow price of finishing constraint is 0, and these two have these shadow prices, and the range of stamping, we established this range. We can just look at it. 105 plus 32.755 gives the same as 137.755, etc. And 15.92, if you 105 minus 15.92, it was something like 89 or something. So we get these values, and you can do for the other values as well. Here for the third constraint, the Q3, I think finishing constraint is, I suppose third constraint is there, Q3, and let me see, yeah, finishing constraint is third one, Q3, and its upper is actually infinity, and the lower is something like 110 minus 11.35, 11.535, 110, sorry, 110 minus 11.35, so it is about 98.65. This is 98.65. Okay, it's not clearing up. Okay, it doesn't matter. Anyway, so we can actually find out the ranges of right hand side, and also the objective function ranges as well. I think enough for today. We will continue with some tutorials later on. Thank you very much.